Okay, so we're going to go through problem solving of right angle triangles. Okay, this is specifically right angle triangles, which means we can use what mnemonic device to solve this? What types of formulas can we use? Sine or so? Yes, good. So, Katoa, and there's also one other one, though we didn't really talk about it.
So was it -1?
Nope, has nothing to do with that. How else, if I have two sides of a right angle triangle, what other formula can we use? Pythagorean's theorem, right? We have our a squared, b squared equals c squared, right? Don't forget about that. That was one of the questions on the test, was to use that. So, in this question here, we have a three-dimensional model, not drawn greatly, but what we're looking for is the height of a cliff, okay? So there is a surveyor, and he has a point here, and he's at a point here. He finds that he is 52 degrees to the point that is perpendicular to, let's say, a tree that he set up, okay? We know that this distance here is 75 meters. This angle is 52. We need to find the height of this, but we only have one piece of information about this triangle, this vertical triangle. This one's horizontal, flat on the ground. This one is a vertical triangle. This one is only 61 degrees, and we don't have any information about any of the lengths of the sides. We do, however, have this adjoining horizontal triangle. We have information about what you can consider the base of it. Okay? And in fact, these two triangles share a side. They share this side here. So what our goal will be, our very first step, will be to figure out the length of that shared side. We'll call it side y. When we find the length of side y, we'll then have information to put into our another formula to solve for our height of the cliff. All right? So we need to find essentially the width of this river below. So because we have this angle, in reference to this angle, what side is the 75? Opposite, adjacent, or hypotenuse? Adjacent, that's right. And we're looking for what side? Opposite. So adjacent and opposite, which of the three ratios will we be using to solve this? Yeah, tangent, right? Yeah, you're right. That acronym is known as TOA. So tangent theta is equal to our opposite over our adjacent. Good. Let's fill out this information. Theta will be 52, right? So tan 52 is equal to the opposite side, which is our y, and our adjacent side is 75 meters in length. Right? We don't really need to include the meters. From here, I need to isolate for y. What do I do to isolate for our y? And how do I move 75? That's right. If it comes over, it needs to be multiplied because that is a division sign, right? So our new question now reads 75 multiplied by tan 52, which is equal to y. We're going to plug this into our calculator. Tan 52 times 75, 95.99. Let's just go with a nice round, approximately 96 meters. You're way off. Okay, so 96 meters is the width of this river. This is 96 meters. And from there, we have this part. So let's talk about our other triangle. I have this angle. In reference to the 61-degree angle, the side y is what? Is the adjacent side also. And we're still looking for opposite. So what formula again? So we're using tangent twice in this. So second time around, tangent, this time it is the angle of 61. Our adjacent side is 96. And we're still looking for our opposite side, which we'll call x. It is the exact same process. In order to solve, 96 will come over, so we'll then have 96 times tangent 61 is equal to x. We plug that in the calculator. 61 tangent times 96 equals 173.1. Well, approximately 173 meters. So according to this question, we had to use this formula twice to figure this out. The height of this cliff is 173 meters long.